السلام عليكم ورحمة الله وبركاته. Welcome to Mazin bin Ghadouba Private School YouTube channel, and this is the next period of grade 11, and the name of subject is transformation of the curve of the function.
In the last video, we looked at sketching graphs. In this video, we're going to move on and look at transforming graphs. We're going to look at three different types of transformations: their translations, reflections, and stretches. We'll work through the theory behind each and then apply them to a range of different functions. We're going to start off with translations. So if we're translating a graph, we don't alter its shape, we simply pick the graph up and move it. We're going to consider two different types of transformations, one in the y direction and one in the x direction. So the first one we're going to look at is the f of x plus a. This is in the y direction, and we can represent this with a vector of 0a. Let's take a function. Let's say we got the f of x is equal to x squared. So this gives us our standard parabola with the minimum point now at the origin, or if you like, the vertex of the origin. So we're going to be opening upwards, and it will look something like so. All we're going to do, if we apply the translation of the f of x minus a, we're simply going to move this now up or down the y-axis. So let's consider now the f of x plus 1. This gives me now a translation vector of 0, 1. So all I'm going to do is pick the graph up and move it up by 1 unit. So if we look at that, this point is going to be 0, 1 instead of 0, 0. Same shape, no alteration in the shape, and then we'll come up like that. Let's consider what I've just done in terms of the equation. So what we've got then, let's say y is equal to x squared. That's our original function. So when x is equal to 0, y is going to also be equal to 0. Let's now look at y is equal to x squared plus 1. So all I'm doing is adding 1 to my function. If x is equal to 0, 0 squared is 0 plus 1, y is going to be equal to 1. Often, if you consider a point and where that's mapped to, it makes transformation significantly easier. Students are sometimes guilty of just learning a set of rules, yet in reality not really grasping what's happening to a given point on a graph. If you do, it will make it fairly straightforward. So that's an example. If we had now the f of x plus, in fact we'll go for minus 3. This now will be 0, minus 3. So we would move the graph down, the original graph, to this point right here, and that would be 0, minus 3. And as you can see, all we've got here is y is equal to x squared minus 3. So when x is equal to 0, y is going to be equal to 0 squared minus 3, y is equal to minus 3. That now gives us a translation in the y direction. Where we can see now the a, this is on the outside of what we call the argument. This is the argument, x is the argument. If it's on the outside, it's going to affect the y coordinates. If it's on the inside, it's going to affect the x coordinates. So the second translation we're going to look at is the f of x plus a. This is slightly less intuitive, as it's now a minus a 0 translation in the x direction. So let's take the f of x again, and this is going to be x squared. So what we've got then is x squared. So we'll place this on like so. So that's x squared. So the f of x is equal now to x squared. Let's look at the f of x plus 4. This is going to give us now a translation of minus 4, 0. If we consider this point right here, this point is 0, 0. So if I put 0 in, I get 0 out. Let's look if I had now x plus 4 all squared. So we could say that y is equal to x plus 4 all squared. Consider now, if x is equal to 0, y is going to be equal to 4 squared, which is 16. So if I now consider when x is equal to minus 4, minus 4 plus 4 is 0. Y is going to be equal to 0. Hence, why we move this now in the opposite direction to what you expected. So this point now is minus 4 comma 0. So all we've done is move that across. We will see now that the curve comes up. There's no alteration in the shape, and this point is 0 comma 16. So we can see now we're translating the shape. We're moving it now to the left by 4 units. This is on the inside, the A is on the inside, therefore it's affecting the x coordinates. So if we had a look now, let's say we had the f of x minus 3, that would move the graph now to this point just here of 3 comma 0, and we'd end up with something now like so. So let's just sketch that up, and it would look like that. Now just think about this. All we've got here is y is equal to x minus 3 all squared. So if x was equal to 0, y would be equal to minus 3 squared, which is 9, and that gives us this point just here, which is 0 comma 9. Now if we took x to be equal to 3, then that's going to give us 3 minus 3, y is going to be 0. So to achieve the same y coordinate, we have to now simply move everything by 3 units to the right, as we're going to be subtracting that value away. In the same way, if we consider now, if we move this 4 units, then we'd need to subtract away the 3 to get the same y value. So these are translations. No alteration in the shape. If A is on the outside, it's affecting the y. If it's on the inside of this argument right here, it's affecting the x. Let's now move this on and look at combining translations. So if I have now the f of x minus 2 plus 4, then what we're doing with this particular one is simply now moving 2 to the right and 4 up. If we had the f of x plus 1 plus 3, this one I'm going to move 1 to the left and 3 up. If we had the f of x plus 3 minus 4, we're going to move now minus 3 minus 4. If we had the f of x minus 1 plus 5, we're going to move 1 to the right and 5 up. So let's go ahead and take the f of x to be equal to x squared again. If I apply this one, what I have now is the following. I would have now the f of x minus 2 will be equal to x minus 2 all squared. So instead of evaluating x, I'm evaluating x minus 2 plus now 4. You might recognise this as the completed square form, and we've looked at completed square form. So this tells me that the minimum point now is at 2, 4. All we've got here now is this point. So this is 2, 4, and we've got now the parabola. The minimum point here is going to be 2, 4, and we can see that that is a translation of 2, 4. I've moved from 0, 0 up to this point right here, and that's the completed square form. So this one right here, now we would have x plus 1 all squared plus 3, and we know that that minimum point would be now minus 1, 3. So minus 1, 3 is going to be about there, as we're taking this to be the positive x squared. So now you can see in terms of the graph transformation, how the completed square form just gives us these two simple translations in both the x and the y direction. So there we go, translations. We don't alter the shape of the graph, we just move it. They're translations. Let's move